What's poppin', dogs? Mr. Allen here, and we're about to write this rational expression as a single fraction, and we're going to list any domain restrictions. First thing we got to do is look at our denominators. These ones are the same, so we can just add our numerators. X plus 3 plus x plus 2, well, that's going to give me 2x plus 3 plus 2 is 5 over my x minus 1. Easy peasy. But I got to list the domain restrictions. So if I look at my denominator, x cannot equal positive 1. That is it. Done with this dope problem. Woo! All right, next one over here. We do have like denominators once again. All right, but I got some traction going on. We got to be careful with this. All right, so this negative right here needs to get distributed to both the first term and that second term. So when I rewrite this, I'm going to have 5 minus 2x minus 9 over the common denominator of x plus 2. Woo! Beautiful. Now, I can combine like terms if there are any. In this case, there are. We're going to have negative 2x minus 4 over x plus 2. All right. A little bit further. Can I factor that numerator? Yes, they both have a negative 2 that I can factor out. Leave me with x plus 2, and now I have x plus 2 right here. These two can cancel out, leave me with negative 2 for my final answer. But those domain restrictions come from its original form before any simplifications. So I got to look at my denominator that got canceled out, which was x plus 2, which means my domain restriction is x cannot equal negative 2. But what the heck? I have negative 2 left over. X cannot equal negative 2. That's okay, man. We're not solving here, right? It's simplified down to negative 2. This isn't saying that x equals negative 2. It's just saying it's going to be simplified down to negative 2 once everything's canceled out. But we can also not plug in negative 2 into the original because I'd have 5 divided by 0. I'd have something divided by 0, right? That's all that a domain restriction is doing there, is saying I can't plug in negative 2 for x, okay? Because that would make my denominator 0. I can't plug in positive 1 for x. It would make my denominator 0, thus it's undefined. This just simplified down to negative 2. It's not saying that x equals negative 2. So once you get into solving rationals, it can get a little bit confusing like that. This is a very rare case where that happens. All right, that's pretty dope. That's pretty awesome. And America.